So next up, I want to look at our VPC module and see how we can leverage a community module to make this a little bit cleaner for ourselves. Now, our VPC module has a lot of stuff, right? And we can go on to main and see that creates our VPC and subnets. And then we have other stuff, right? We have our gateways. So we have to create our internet gateway, our NAT gateway, and then we have some routes and route tables. And then we also added some security stuff to create 2 security groups and manage the outputs and variables for all that stuff. So we followed a pattern here that's kind of typical. It's not overly complex. It's kind of a simpler pattern where we just have 2 subnets per availability zone, and each subnet is a public one and a private one. So there's 1 public and 1 private subnet per availability zone, as I went on about in length in other videos. Now, I want to use a community VPC module, and much to my surprise, it actually used very much the same ideas of how to configure it. Now, the VPC module has a lot of stuff going on. It creates a lot for us. It'll do VPCs and subnets and routes and route tables, internet gateways, NAT gateways, and more than we did. But it also does all the stuff we did in one kind of logical grouping of places, in one place, in other words. And I like that a lot because that'll simplify our configuration code quite a bit. And we can see from their example, it's kind of similar, right? We have the availability zones we're going to create in. This is different per region. In our case, we're going to do US East 1A, 1B, and 1C, US East in our case, and then private and public subnets. This actually divides up the subnets how we want to create them. We can say, I want 3 private subnets and 3 public subnets. It'll do 1 per availability zone. And we'll tell it which IP addresses to create, right? Because our module, our VPC module, did math for us to segment this out, and that's something we can still do. But this module wants to be told how to set up the subnets. And then we can enable NAT gateways and other good stuff too. Now, the NAT gateway is interesting. There are NAT gateway scenarios. The default is actually 1 NAT gateway per subnet. So in our case, this would end up with something like 6 NAT gateways, which would be super expensive. Or actually, I'm sorry, 3, because we have 3 private subnets, right? So this will create 1 NAT gateway per quote unquote private subnet. Our case, what we did is a single NAT gateway, which is a scenario that this has as well if you add these following 3 options, which is very nice. Okay, so back to our setup, we can go ahead and try to convert our VPC here into one that uses that community module. Let's go ahead and actually start with variables in our VPC module. We're going to have a new one. We're going to need to pass our module the availability zones that we want, because then we can then pass that on to the community module. So let's go ahead and let's see what that looks like. Infra-env and VPC CIDR will stay the same. Variable AZs for availability zones. It's a type of list of string. The availability zones to create subnets into. So pretty simple. We're just going to create that new variable and pass that in over here. So that'll be a new variable to add in here. AZs equals some list of strings. Now, our public subnet number and private subnet numbers, these are things that we can change. We can go ahead and just say public subnets and private subnets, because we're not going to do this setup where the module itself calculates this setup for us. Instead, we're going to let the community module do that, and we can just pass it what it needs to figure that out. And in that case, it just needs a list of public subnets, which we saw up here. We're going to give it a list of private subnets and a list of public subnets to get spread amongst the availability zones. Okay, so this becomes simpler. This is just a list of strings now. And I'll actually just copy and paste from our notes here. Type list of strings, description, subnets to create for public network traffic, 1 per availability zone. And I'm not going to have a default here because I want that to be something that is required. Do the same with private subnets. Perfect. That is basically it for this. So we have a new variable, AZs, and we're going to change our public and private subnet so it just gets a list of strings. So back over here, we'll see that we are passing it public subnets and private subnets. So we're going to have to update this definition with this stuff as well. I'm not going to talk about outputs just yet. We'll do that after we make our next changes. So we can dive right into our main.tf file and start making changes. Okay, so our main.tf file has our VPC. It has subnets, and that's it. We can get rid of all of this. And I'm going to paste in our definition for module VPC that pulls in the community VPC module. Now we can also get rid of the gateways file because that community module is going to handle all this gateway setup as well. So we can just go ahead and delete that file. So we're going to name it Cloudcast VPC. Again, I think our tag with name here is going to override that, but that's okay. CIDR is the var VPC CIDR, so we're going to do the same thing there. AZs is the list of availability zones. This is the setup I showed you that uses a single NAT gateway. So these are the settings to use for that scenario. And then private subnets and public subnets was the list of strings for the things that we wanted, right? The subnets that we wanted. And then we just gave it some tags. And really, that's it. Otherwise, this is functionally equivalent because this is going to do all the work of all that other stuff we did. Subnets, routes, route tables, NAT gateway, internet gateway, all that stuff. It also intelligently adds the NAT gateway to a private subnet and the internet gateways to the public subnets, which is what makes them private and public. So now we can actually go ahead and update our outputs. Okay, so a VPC ID, again, we're not making a VPC directly here. We're using the module. In the module, we named it VPC, and we can just go ahead and get, I believe, the ID. Let's go ahead and check that out, though. I think I might be wrong there. I think it's actually VPC ID for outputs. So I'm searching for VPC ID. This is the default one, so that's the ID of your default VPC, which is an output it provides for some reason. But the one it creates for you is this VPC ID, so the ID of the VPC here. So we'll go ahead and change that to VPC ID. So module.vpc.vpc ID. Same thing here. We want the VPC CIDR block that we created. So that is module.vpc. And I believe this is VPC CIDR block. Let's copy and paste that. Head back to our documentation and find that here. Default again is 1, and then the VPC CIDR block is another. Perfect. VPC public subnets. We no longer need this fancier map where we get the subnet ID and its CIDR range because those are split up into different variables within our thing here. So this is, let's see, public underscore subnets, I think is the variable name. Yeah, public subnets, a list of public subnets inside the VPC. Okay, so here this just becomes a value of module.vpc.public subnets. And for private subnets, similarly, it is module.vpc.private subnets. And these remain the same because these are things that we're going to manage in here, the security groups. That is a thing that is logically grouped within our custom module here, and it's not handled inside the VPC community module, so we get to keep those here, and we see that they remain the same, essentially. Let's see, except there'll be a few things to change in here, I believe. Yep, so we can go ahead and replace this with module.vpc.vpc underscore ID. And down here we see that we got the CIDR block, right? So that's another instance of getting the module.vpc.vpc CIDR block. Let's just make sure that's correct in my outputs. Yep, okay, so that's the same there. Okay, so our security groups are updated as well. Our outputs are updated. Our variables are updated. Our main.tf became very simple, and we got to delete the gateways file because our VPC module, the community one we pulled in here, is going to handle that for us. So let's go ahead and see if we messed anything up. First thing we're going to do here is Terraform init once again because we have a new module and it's downloading and grabbing the version we defined. Okay, so to actually get this to work, we just need to edit cloudcast.tf and fill these things in. Now the AZs are pretty simple. It's going to be US East 2A, 2B, and 2C. And then the public subnets and private subnets. We could just go ahead and hard code one of these, something like 10.0.1.0/21. I think something like that is valid. And the /21 is what we essentially used originally as well, using the CIDR subnet function, right? In this case, we have something new we can use. We can use CIDR subnets, plural. You see how the autofill there? So we have net, was what we used before, and subnets, plural. But let's actually go ahead and play in terminal to see what that looks like. We can run Terraform console, which gives us a little console that we can use to test some things out. And I have a error here because it actually is reading our Terraform configuration, but that's not going to stop us from playing around here. We can use CIDR subnets to see what this function is going to give us. Now it wants, for the first thing, the main CIDR range that we're going to use, which is /17 in our case. And it's going to give us nothing in return, a list of nothing, because I haven't defined anything. Now, if you remember before, I used the for the, I think it was the new bits item for this, and that gave us a /21, right? Because it just added 4 to 17, and it is going to give us one subnet here with new bits of +4 and give us the /21, which is going to be about, I think it was like something like 2048 IP addresses that we could use in that range. Now, this is cite our subnets, plural. It can give us multiple ones. So we can actually give it multiple arguments, as many as we want. And this is going to go ahead and create 3 subnets, 3 contiguous ones, right? So 10.0.0/21, 10.0.8/21, 16-21. So these are all /21 subnets that are kind of one after the other in terms of IP address ranges. Now, we need 3 for public subnets and 3 for private. So we actually want 6. So we can go ahead and say 4, 4, 4, and we'll get 4 total. And then we want 3 of those to go to public and 3 of those go to private. So we can go ahead and add the slice function on top of that. And we can slice here starting from the 0th item and get 3 items. So that's the first 3. And then for the next 3, we can go ahead and start at the 3rd index, which is the 4th item in the list, and give us 3 items as well. Okay, and what I did wrong there is 3 and 3. This is start index and end index, right? So we can start at the 0th and go to the 3rd index, and then we go and start at the 3rd index and end at the 6th index, which will give us the last 3 items there. So let's go ahead and use that. I'm just going to go ahead and copy and paste this one, and that'll be what we define here. And then I'll just copy and paste here and move it up here. We're going to start at the 3rd index and end at the 6th index for here. And this will divide up our 1, 2, 3, 4, 5, 6 subnets that we have it split it up to. And 3 will be assigned to public, 3 will be assigned to private. Let's go ahead and do another plan and see if it doesn't like anything else. All right, this is a thing I missed. So subnets equals key cloudcast for EC2 worker. Up here, we originally returned a map, and the key for that map was the subnet ID, and the value for that map was a CIDR range. But we no longer have that. We don't need to get the keys. We can just go ahead and get the module VPC, VPC private subnets directly for our EC2 instances. Okay. Perfect. And we got 34 to add, which is everything again, right? So our VPC module is going to create subnets. Some will be public, some will be private. It will create route tables and route table associations, internet gateway, an EIP for our NAT gateway, EC2 instances. And I probably skipped the NAT gateways and all that good stuff somewhere. This is doing all the things we need. We can see by the number 34, it's probably going to create the exact same number of resources as well, because we happen to model our VPC module just as the community tends to do as well, which is just based on my experience. So we have simplified our VPC module here by using a community one. The community one is going to be, better maintained than what we write ourselves. It has a lot of features to give us different configuration options without us having to figure out how to code those up all ourselves. And like I said, it's simpler for us. We got rid of the gateways file. We can still logically group everything because we can still create the security groups that we need here, which is, in my view, something that belongs in the VPC or kind of general networking module that you might create for yourself. And that's basically it. We have a good example here of the pattern that I like, where you create your own modules still, but in those modules, you use community modules to simplify your own configuration, while also giving you the ability to logically group together the things that you want together in one module, which, again, are things that might not be in the community module. So for example, I want security groups here in our VPC area, but the VPC community module doesn't have security group support. So what I do is create my own module here, and I use the community module, and then I add on top of it the other stuff that I think is related. We did that for security groups here, and with our EC2 instance, we did that with the elastic IP addresses.